All right, here we go. Let's do another example where we're going to sketch the curve, a curve 2 cosine 3 theta. Okay, so now let's look at how we do this. So symmetry, okay. So looking at it, we've got a function of cosine, okay. So it's going to be symmetric with respect to the polar axis. So r equals a function of cosine theta. And so that implies that it's symmetric with respect to polar axis. Okay. And then what else do we know? Okay, maximum value of r. So where does the maximum value of r occur? What's the maximum that cosine can be? 1. So the maximum that this can be is going to be 2. And when does that happen? So absolute value of r equals 2 when what? Well, okay, so when cosine is 1, right? When cosine is so that means when 3 theta, so cosine is 1 when 3 theta is equal to what? 0 pi, right? Because absolute value of r, right? Absolute value of r. So pi, 2 pi, right? And so on. Okay, so that would mean that when theta is equal to 0 pi over 3, 2 pi over 3 pi, right? Okay, so now what about the zeros? When is r equal to 0? Okay, r is equal to 0 when what? R is equal to 0 when 3 theta is equal to what? Well, when this is equal to 0, right? Cosine is equal to 0 at pi over 2. So when 3 theta is equal to pi over 2, 3 pi over 2, right? 5 pi over 2, and so on. So that means that when theta is equal to pi over 6, pi over 2, right? 5 pi over 6, right? And so when we plot this, and again, plot some points, and in this case, what I would do is go from 0 to pi over 2. Right? So what you'll notice is if you go from 0 to pi over 6, so at 0, you're at 2. So let's say 1, 2, 1, 2, 1, 2, 1, 2. So we got 2, 2, negative 2, negative 2. So we're going to start at 2. When theta is 0, we're going to be at 2. When we're at pi over 2, it's 0. Right? So if we plot some points, we're going to go start from 2 and we're going to go 0. So as we're going from 2, we're going to go to 0. So we're going to do something like that. To 0, right? And then what happens from 0 from 0 to pi over 3? Right? So if we continue on to pi over 3, or excuse me, pi over 6, I'm sorry. So if we go from 0 to pi over 6, we go from 2, where's pi over 6? Oh, right here. Pi over 6, 0, right? So if we go from 0 to pi over 6, we go from 2 to 0. Boom. Now if we go from pi over 6, right, to pi over 3, right? And then if we go to pi over 2, watch what happens. It goes like that. So in one day, so from 0 to pi over 6, to pi over 6, to pi over 3, and then to pi over 2, we did this. And so if we go here, if we keep going from here, like so, if we keep going, what's going to happen? We're going to keep going up like this. And then we're going to go down like this. Oh, hold on. Not what I wanted. So if you go down like this, right, it's going to go through here, like so. There we go, like that. And we're going to get something like this. So we get this rose kind of shape. So if we go from here, we're going to go from here to there. So 0 to pi over 3, and then to pi over 6, right? And then to pi over 2. And then the 2 pi over 3. And then the 5 pi over 6. And then the pi. So from 0 to pi, this is what we have. So it goes like this. So it goes like this, right? From 0 to pi. And then if we go from 0 to 2 pi, it's going to trace it twice. So it's going to go this way, all the way around. It's going to come back to the starting point, and then it's going to trace it again. So, and notice also that we've got 1, 2, 3 petals. And we've got a 3 here. So 3 theta correlates to 3 petals. Now it's cosine 2, so just keep an eye on, just be aware of that. Okay? And then for the checkpoint, there's a sine. So we use sine, and notice what happens with the sine of 3 theta and how that affects the graph. All right. That's it. Have a great day.